Hello, guys. I hope you're doing well. Welcome back to part 8, the AQA GCSE Higher Paper 2 Maths Run Through. Last time it was a walkthrough. No, last time it was a work through. Now it's a run through. Anyway, we've got question 33. Rearrange this to make D the subject. Okay. We've got D written here twice. Let's see what we can do. If we multiply both sides by D plus 3, we get C multiplied by D plus 3 in a bracket, which equals 4 minus D, applying a bit of cross multiplication. Now we've got a problem where we've got D's on both sides of the equals. So I'm going to expand, first of all, the left-hand side. So that gives me C times D, which is CD, and then C times 3, which is plus 3C. And that's equal to 4 minus D. Now what I'm going to do is I'm going to get everything with a D on one side of the equals and everything without a D on the other side of the equals. So if I add D to both sides, I end up with CD plus 3C plus D equals 4. If I take away 3C because that does not have a D, I get CD plus D is equal to 4 minus 3C. Okay, if I now factorize D, because I've got everything with D on one side, that gives me a single D, like that we need. So C plus 1. So I factorize the D, and I've got C plus 1, and that equals 4 minus 3C. Then, if I divide by C plus 1, I get D equals 4 minus 3C over C plus 1. So this is acceptable as an answer. I'm going to write this here. Now I have to address another thing, just in case people get confused. At this stage, this is the final answer, by the way. But at which stage? This stage, I could have chosen to take everything with the D on the right-hand side and everything without the D on the left-hand side. So, having rearranged it that way, I would have had 3C minus 4 equals minus D minus CD. Okay, then I would have had 3C minus 4 equals D, open bracket, minus 1 minus C. Then dividing, I would have got 3C minus 4 over minus 1 minus C equals D. This is pretty much the same thing, just realizing that you'd have the top, which can be written as, well, let's leave it as 3C minus 4. The bottom can be written as, factorizing out a minus 1, I'd get minus 1 times 1 plus C, which is equal to 3C minus 4 over minus 1 times C plus 1, just changing 1 plus C to C plus 1. And then if I'm dividing top and bottom by minus 1, well, the top bit becomes minus 3C plus 4. The bottom bit, well, minus 1 divided by minus 1 is just 1. So that'd have C plus 1. And notice how that is the same thing as this. Now, if the red writing did not make any sense, do not worry. The blue is absolutely fine. The red was just in case anybody decided to apply my step of getting everything with a D on one side and everything without a D on the other side, the other way around. So if you decided to take D's on the right and without D's on the left, then the red would have been your way to follow. Okay? Let's go on to the next question. We've got lots of rearranging stuff. Oof, wow. So, oh dear. Let's just do this. Okay, so we've got 34, rearrange P equals R plus 3 to make R the subject. Well, we've got this plus 3, so we do the opposite of plus 3, which is take away. So we end up with P take away 3 equals R. Okay, so which one has P minus 3? Okay, there's R equals P minus 3. That works. Here we want to rearrange to make G the subject. So if we take away 2 from both sides, we get F minus 2 equals 3G. And then dividing both sides by 3, because it's times, gives us F minus 2, all divided by 3, equals G. So G equals F minus 2 over 3. Next, we want to multiply out x squared times 4 minus x. Well, x squared times 4 is 4x squared. X squared times minus x is minus x cubed. So our final answer is 4x squared minus x cubed. Okay, moving on. We have this question. The cumulative frequency graph shows information about the masses of 50 apples. How do you like them apples? Right. It says use the graph to estimate the median mass of apples. So with a cumulative frequency graph, we always look at the highest cumulative frequency and go halfway for the median. So the cumulative frequency goes up to 50. So half of 50 is 25. So we're going across. And it ends up here. There. And then we go down. Trying to be so careful with this. Normally be using a ruler. Boom. Okay, that lands on about 106. So our estimate would be 106 grams. Okay. Next, it says estimate the proportion of apples that have a mass greater than 115 grams. So what we need to do here is go to 115, go up. Oh dear, whoa. That is meant to be a straight line, guys. It's meant to be a straight line. Right, so boom, 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 there. Then go across. Focusing so hard. Right, so that cumulative frequency there is 42. That does not mean that we have roughly 42 apples greater than 115. We're looking at what's this way, right? Greater than. So if we follow it round, we're looking at everything above. So that means between this number, 42 and 50. So 50 take away 42 gives you 8. So the proportion is going to be 8 out of 50. Okay? That is a proportion. Or if you like, you can write it as 0.16. Either one is fine as a final answer. Okay? I prefer 0.16 in this case. 8 out of 50, the only reason I didn't like it was because it wasn't a simplified fraction. That's just preference. Anyway, now we have this question. This is actually hurting my eyes. Woo. Waist measurements of 40 men. How many men have a waist measurement of 85 centimeters or less? Right, so again, we look at the 85. We go here. And then we go across. And then that's 5. And again, we're looking at less, right? So everything here. So the difference between 5 and our smallest, which is 0. So 5 take away 0 equals 5. So how many men have a waist measurement of 85 centimeters or less? That's 5. What is the median waist measurement? Well, this graph goes up to 40. Median, we go halfway. So half of 40 is 20. So we go here. Then we go down. Right, what number is that? Looks like 101 to me. So the median is 101 centimeters. Then it's asking, what is the interquartile range of waist measurements? So interquartile range is upper quartile take away lower quartile. Okay, so we've got upper quartile take away lower quartile. So the upper quartile, so we go 3/4 of the way up. So 3/4 of 40 is 30. We go across. I'm actually trying really hard. Over here, then we go down. Oh dear. So that's 106. So the upper quartile is 106 because we read 106 from the graph. Take away the lower quartile, we go 1/4 of the way. So 1/4 of 40 is 10. So let's change the colors. Pink, I think, is another one that's bright. We can see it. Go here, go down. That's 93. So our lower quartile is 93. So we're doing 106 take away 93. Oh my gosh, do you know what? I'm going to embarrassingly use a calculator. So I've got 106 take away 93, and that's 13. So the interquartile range is 13. Okay. Next question. ABC and ACD are triangles. Work out the size of angle X. Well, we want to work out angle X, but we've got so much information here. Ooh, I like this. Okay, so we don't yet have enough information to work out angle X, but we can work out the side length AC. Let me call this Y. And that's just using basic trigonometry, so SOHCAHTOA. There are many ways of doing this. I'm going to do this the way that I see loads of people do it, which is using those little triangles that we all love. Let's first of all label this triangle. So we've got hypotenuse. We've got the 49, so this Y must be the opposite. And therefore that leaves this as adjacent. Okay. So let's just also write SOHCAHTOA. I'm going to write it specifically like this. Soh-ka and toa. No, there's no H, so just toa. Okay. So we're given the adjacent. So we want adjacent in our calculation. And we're trying to work out opposite. So which of these sets of letters have both O and A? Well, it's this one over here. So that tells us that we're using tan. So let's replace everything with what we are looking for. So T stands for tan, and that's tan of the angle, which in this case is 49. So tan 49. O is what we're trying to work out, so that's Y. And adjacent is 16, the A. So Y is going to be equal to 16. I don't know why I wrote it like that. Let's write it the other way. Tan 49, and it's important to use the brackets, guys. Close that bracket off, times 16. Okay. Let's just work out what that is. Tan of 49 times 16. Okay. Ideally, I'd want to use the exact answer, but just for the sake of ease and because people might want to see a number, like a number written out in the conventional way, should I say, I'm going to say 18.40589. I'm going to write all those decimal places. 18.40589. Okay, now I've got this second triangle, which is not a right angle triangle, so I can't just use SOHCAHTOA. I've got to use something different. I'm actually going to use the sine rule for this. Okay, so when you have a side length and an angle opposite, or you have a pair of those things, we can use the sine rule. So the sine rule states that, in this case, x, not even x, it states that sine x, sine of the angle, over the side opposite, so the side opposite that x is the 18.40589, is equal to sine of a different angle, in the same triangle, of course, divided by the opposite length of that. So opposite the 35, we've got 20. Okay? Then I'm going to rearrange this because I want sine x by itself. So sine x is equal to sine 35 over 20 times by 18.40589. Then x is equal to the inverse sine of this answer here. In fact, I'm just to not confuse, I'm going to write that bit in blue. So I'm just taking the inverse sine of everything that I just wrote here. So sine 35 over 20 times 18.40589. Okay, so with that, I can just put that right into the calculator and that should give me my answer. So we're going to sit here awkwardly whilst I do that. Inverse sine of 35 over 20, was it 20? Yep. Multiplied by 18.40589. And then close that bracket. And then boom, we get an answer. We get 31.860926 dot dot dot. Well, let's just say it's equal to, oh gosh, that's supposed to be a dot dot dot, not a line. And then let's just say that's equal to 31.86 to 2 decimal places. So 31.86 degrees. Right, that concludes this video. I will see you in the next one.